Hi guys, today we are going to start with exponential equations, and that will take us through the rest of the week. We have looked at exponential equations before, and just remember that means that there is a variable up in the exponent. So we have looked at the derivatives, and now we want to go ahead and look at how to integrate them. So if we remember that the derivative of, we would just pay attention to e to the x, okay, although we could do other logs as well. But the derivative of e to the x was just e to the x, okay? And if we wanted to take the derivative of e to the u, it was just e to the u. So pretty basic functions, okay? So today we want to look at integrating them. And so, oops, believe it or not, it's pretty easy integration formulas. Okay, so if we have e to the x dx, it is just going to be e to the x plus c. Okay, and if we have a more complicated exponent up in the power, then it just looks like this, e to the u plus c. Okay, so let's go ahead and see what we have. Okay, and the reason we look at e's right now is because they are the inverses of natural logs, and so these are separate chapters. Remember, we did pull in natural logs and exponentials when we were looking at derivatives right at the end. And then, so this is the end of us looking at the integrals. Okay, this will be the last function we look at for a while. What I plan on next week is looking at areas between two curves and looking at a few special topics, and then you're almost going to be done. So this is the last main integral topic we will look at for a while. Okay, so let's take the integral of e to the 3x plus 1 dx. Okay, and we want to integrate that, and I forgot my highlighter again. Give me just a second. I will be prepared one of these days. Okay, so let's let u be our exponent. Okay, so u is equal to 3x plus 1, and we do need to go ahead and take the derivative with respect to x, so we get 3dx. Okay, so if we look at what we can replace our exponent, right, with u, but we still have that d to the x we have to rewrite. And so we are pretty close, but how do we get dx by itself? We just divide by 3. So we have a third du equals dx. Okay, and so now we can get our x's replaced by u's. Okay, remember that was our whole goal here. So we now have e to the u du, but we have to have a third of that, okay, because that is what replaced that dx. Okay, and so now if we follow our rule, it said that the integral of e to the u du is just e to the u plus c. So we end up with 1/3 e to the u plus c. So we end up with 1/3 e to the 3x plus 1 was our u, okay, plus c. And we are through. Okay, so it's just going to be a picking out what u is, integrating it as e, and then replacing u. Okay, so it's just going to be a substitution game, pretty straightforward. Okay, so what if we have this one, we go from 1 to 2 of e to the 1 minus x dx. Okay, so the difference here is now we have a definite integral because we do have a lower bound and an upper bound. So in this case, we're actually going to get a number, right? We don't have to tag that c on. We can either put this in our calculator or leave it in terms of e, but we are going to get a answer this time because we have 1 and 2. Okay, so we're going to start with u, and we want to let it equal our exponent, which in this case is 1 minus x. Okay. And then if we take the derivative, we get negative x. Sorry, we just get negative 1 dx. Okay. And if we notice here, we do need to replace that dx. And so right now we have negative dx. So all we have to do is divide by a negative. And so that makes negative du. Okay, so if we go replace, we now have e to the u, du, but it needs to be a negative du because of this dx right here. Okay, and so we'll replace. Okay. And so now we integrate, and the integral of e to the u is just e to the u. Okay. And this time we do have our bounds, so we have from 1 to 2. Again, that was a negative on the outside. Okay. So when we evaluate, we do the second number first, or the top number. So I'm going to just put that negative on the outside. Okay. And we have e. We got to put that u in. I forgot that. I'm sorry. So e to the 1 minus x is what we have here. Okay. So I forgot to replace my u, but now we can do that. Okay. So we have a negative, and then we have e to the 1 minus 2. Okay, and then there's always a minus when you do your top limit minus your bottom one. So minus e to the 1 minus 1. Okay, and so if I simplify, I have a negative out here. E to the 1 minus 2 is a negative first. Okay, and then we have a minus turns into a plus. And we have e to the 0. Okay, so this becomes e to the negative first. And what's anything to the 0 power? It is 1. So this is a perfectly fine answer. Okay, I lost my negative though. That's not okay. But this is also, and probably the one that you would see the most, okay, is 1 minus 1 over e, because a negative exponent does take it down to the bottom if it's on top. Or I might even see e minus 1 over e. Okay, so lots of different ways I could see that answer written. Okay. This last answer is just me getting a common denominator. Okay. So again, I do not have a plus c on this because I do have a starting point and an ending point. So you actually get a number. Okay. Could I plug that in my calculator? The answer is yes. If you'd rather have an answer that's approximate. So we have e, let's see, e minus 1 divided by e gives you about 0.63 if you were curious about that. Okay. So there are a couple examples. Okay, so what about another one? So I have the integral, of 5x e to the negative x squared dx. So here you just have a more complicated exponent. Okay, but we can deal with that. All we have to do is let u equal up there. So u equals negative x squared. So we take the derivative with respect to x. So that's negative 2x dx using our power rule. Okay. So we've taken care of this, right? That's u, but we're still missing the 5x dx. Okay, we've got to be able to take care of that. Now we're pretty close over here. We're at negative 2x dx, okay, but we need it to be 5x dx. So first thing I would do is divide by negative 2. And let's see where that gives us. Okay, that gets us to x dx, which is really close. We want it to be 5x dx, So you can multiply by anything you want to as long as you do it to both sides. So let's go ahead and do by 5. Because now I have 5x dx, and that's what I needed up here. Okay? So again, you can manipulate it however you wish. You just want to be smart about it so that you can replace. Okay? So let's go replace. 5x dx is negative 5 halves du. And then I have e to the u. Okay? So now if we integrate that, I have negative 5 halves e to the u plus c, which means I get negative 5 halves e to the negative x squared plus c as my final answer. Okay? Because I have u, and then I just went back in and plugged in for u. Okay? And let's look at a couple more. So these might look more complicated than they can be, I guess, but if we might as well try and make them fit our pattern. So this one looks a little more complicated. I have e to the 1 over x, okay, dx all over x squared. So if we're lucky, this will follow the pattern that we have. So let's let our exponent be our u, okay. So we're going to let u equal our 1 over x. And just as a reminder, that is negative 1 as a power, right? X to the negative first, that's the same thing. So when I take the derivative, I bring it down, right? And then I subtract a power. And so that would be negative x to the negative second, which is negative 1 over x squared. Okay? Which actually is really good news, because if we look over here, what we need is a 1 over x squared, right? Because the x squared is on the bottom. And that's what I have here, except for a negative. So negative du equals negative 1 over, oops, equals 1 over x squared if I divide by a negative, okay? So it looked bad at first, but actually this is all taken care of here. And so we can replace, and this is e to the u du, but a negative on the outside. Okay, right, that's what happened here. We replaced. Okay. And once we have eu du, the integral of that, we've learned that that's just e to the u plus c. And that negative comes from here. So we get negative e to the 1 over x plus c. Okay, so again, just try to make it fit that pattern of e to the u and finding out what du is. Okay. And one last one. Let's say I have e to the negative x to the 4th times negative 4x cubed dx. Again, it looks complicated, but if we think about it, I see an x to the 4th. I also see an x to the 3rd. So there is that derivative relationship. So as long as that higher power is up in the exponent, we should be good to go. So we're going to let u equal the negative x to the 4th. And then if we take the derivative, we get negative 4x cubed dx using the power rule. Okay. And so actually this one is perfect because that takes up our negative 4x cubed dx, which is just du. Okay. So this one is cleanly written as eu du, which the integral of e to the u du is just e to the u plus c. Then if we replace e, or if we replace u, excuse me, we have e to the negative x to the 4th plus c. Okay. And so that is how you integrate exponential functions. We will have an assignment over that tomorrow. Not very many, because I mean it's just a, right, they're just going to throw different numbers at you. So it's a variation on a theme. So at the most 4 problems like we've done in the past, but we'll see how that goes. And on Wednesday, we'll look at some that are a little bit harder. Okay, and then my plan was on Friday to look at some area. But let me know if you have questions, and no assignment today, but you will have one tomorrow. So have a great day.